Hey everybody, it's Mr. N here, and today we are going to do the second section in Chapter 10, which is finding arc measures. And let's get started with these notes. First, a couple definitions. First of all, a central angle is an angle whose vertex is the center of a circle. So let's go ahead and draw a circle, and I will show you what this central angle looks like. A central angle would be from the center here, and it creates this angle from the center, and that would be your central angle. Now, it could be anywhere. It doesn't have to be specifically there. Let's put another circle on here, and it could be anywhere. Let's do this one. Here's from the center, and we can make it like this and like that. Now, I guess the question you're asking is, can this one be right here on the outside a central angle as well? So if we look at the definition says an angle whose vertex is on the center of the circle. So as long as the vertex is the center of the circle, we can have this as our central, this one right here, I should say, is our central angle, or this one on the other side. So either one. Well, what happens is we have to classify these. And we can classify them as a major or minor arc of the circle. So the central angle will create these arcs. So you have this little arc, and you have that arc. This would be the minor arc, that would be the major arc. This would be the minor arc, that would be the major arc, just like they say. Minor arc, major arc. So looking at the definition, which we have right here, and I will move this up so you guys can see it a little bit better. Okay. A minor arc is an arc whose points are on or in the interior of the central angle. So here's my central angle. This would be my minor arc because all the points are on or in the interior of that circle. And the major arc would be this one right here, and it's whose points are on or in the exterior. So all these that are in the exterior, that would be the major arc. That's how it would be classified. So then you are wondering, what if it was cut in half like this? Well, if it's cut in half and the endpoints of an arc lie on what we call the diameter, then we're just going to call it a semicircle. Then we have adjacent arcs, and these are arcs that have exactly one point in common. So for adjacent arcs, I could say draw on this circle right here. Suppose you had let's do a different color. Suppose you had an arc right here and then an arc right here. These two would be adjacent arcs because this is the only point they would have in common. So if I call this EF, I would name this arc EF, and I name it like that. And then the other one I would name arc GF, and they have this F point in common. So again, as you saw here, when we name the arcs, we'll say the measure of arc AC. And here's what else we have. When we have a minor arc, we have this angle in here that's formed is gonna result in the same arc angle. So the measure of arc AC will be the same as this measure of angle X. So these two will have the same exact measurement. So we can go to the next one, and we can say, if I'm taking a look at this angle in here, this arc, and I can call this angle Y, and I would have to label it this time the measure of arc, and since it's the major arc, I'm going to use 3 letters. I'm going to say it's arc A, D, and C. So for a minor arc, we're just going to use 2 letters. And for a major arc, we're going to use 3 letters. And I can say that this is equal to the same thing as the measure of angle Y. So that's right there. And this would be equivalent to just saying 360 minus angle X. So this angle in here, angle Y, in this example, they called it what I called angle Y. They called the measure of arc ABC. And then, of course, on a semicircle, this will be 180. So this arc measure will be 180, and the bottom arc measure will be 180. And then we would still have to call it the measure of arc EFG, you need that third point, and we would say that this is 180. All right, let's see what else we got here. Let's move this up. So we have the arc addition postulate here, and it says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So what we have here is, if I've got arc, let's use this tool, if I've got arc A to B to C, those two arcs that I'm looking at right there, I can go from, oops, what just happened? Let's try this again. Okay, I can go from arc AB, that measure, plus the measure of arc from B to C to get that full arc ABC. It's just like the segment addition postulate and the angle addition postulate that we've learned. And then we have congruent arcs, and congruent arcs have arcs that have the same measure. Then we've got this theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So as long as you have congruent central angles, then the minor arcs are congruent as well. So remember, we had said that these central angles over here, I don't know why this is giving me a hard time moving it, and we had said these central angles over here, if you had this central angle, and suppose I made another one right in here, and these two were congruent in here, then the arcs would be congruent. If the arcs were congruent, then the central angles are going to be congruent. So it works both ways. All right, so let's move on and see what we can do. And we have congruent circles if and only if they have the same radius. So as long as this radius is the same, then the circles will be congruent. And we could say that this is a rigid motion. We'll talk more about all this in a little bit. And let's move on to the next thing. Let's see what else we have here. Congruent central angles theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So it's basically what we had just said. These two arcs are congruent if and only if these two arcs right in here, I should say, if and only if these two central angles are congruent as well. And similar circles, all circles that we talk about will be similar. Just like if we had similar triangles, we have similar circles. They don't have to have the same radii, but every circle will be similar. All right, so let's do these examples from your student journal. It's going to be page 287, 1 through 11. All right, so taking a look at these problems, the first one says identify the given arc as major, minor, or a semicircle. So if I'm taking a look at arc A to B, this would be a minor arc. For the second one, arc A, B to C, that's a semicircle. From arc A, B to D, that would be major. Remember, because a semicircle would be 180, minor would be less than 180, major would be greater than 180. And then BC would be minor. And angle BAC would be major. We're going to go through and find the angle measurements in a second. And then DAB, oh boy, that's going to be a major. And then arc AD would be minor. And then arc CD, C to D, would also be a minor arc. So now let's find the arc measurements for each of these. What I'm going to start with is the fact that they gave me this is at 40, and they told me that AC is perpendicular to BE. Since this is perpendicular like that, these are 90s. And we know that ABC is a semicircle, so that's going to be 180 all the way around like this for that arc. And if this is 180, then this side has to be 180 from A to D to C, which means this in here will be 180 minus 40, so this arc will be 140, and the central angle will be 140 as well. All right, so let's write these in. So AB we said was going to be 90 degrees. A, B to C, that's a semicircle, that's going to be 180 degrees. AD DB, A to D to B. So let's take a look at what we have. We got from A to D, that's 140. Or I'm sorry, A to B, then to D. So this is 180 plus the 40, so that's going to give me 220. So this will be 220. And then B to C will be 90. And then BAC, B, okay, be careful how we're doing this one. We've got to go from B to A to C. So we always read this in order, from B, then to A, then to C. So from B to A, then to C. So this will be 90, B to A, and then A to C is another 180. So 90 plus 180, that's going to give me 270. And then DAB, so we're looking at D to A, that's 140 we said, then to B, so 140 plus 90, so that would be 230. And then A to D would be the 140 that we had said, and then C to D would be the 40 that was given. All right, let's move this up and take a look at the next questions. On number 9, it says, in circle E above, so we're using this one again, tell whether ABC is congruent to arc ADC. So let's see. ABC, that's 180. ADC, that's 180 as well. And the answer is yes, both are 180 degrees. So then we have our next problem here, 10, and it says, in circle K, get that? Find the measure of arc DE. So let's go through this and take a look at what we have. We know that C to E, that is, because they told me that it's circle K, this is through the center, so this is a diameter. So we know that this is 180 degrees right there. Since that's 180, then the other side will be 180. If this is 55 and that's 30, that gives me a total of 85. So this arc in here will be 95 degrees. So this angle, which would make this arc 95 degrees. So if we wanted to find D to E, we know that this is 55 degrees. I mean, I didn't have to go through all that trouble. I'm just showing you how to do all this stuff. I could have just done what I'm doing right now. Since this is 55 in here, that's 55 there, because this goes directly through the center. That goes directly through the center. I get vertical angles. I know that that's 180. So 180 minus the 55 would give me a total of 125 for that right in there. So the measure of arc D to E, this angle is 125, so this arc will be 125 as well. Okay, find the value of x. So let's take a look at this. Let's move this up. And this is our last problem here. Then find the measure of arc AB. So to find the value of x, I'm just going to go through and tell you what I know about this whole circle. I know that this is 40 in here. If this is 7x plus 2, that's 70. And this is 5x, so that'll be 5x inside. So what I do know, since I'm given every single arc on here, when I add up all these, I'm going to get the total for a circle, which is 360 degrees. So I can say 5x plus the 40 plus the 70 plus the 75 plus 2x. All of this comes out to be 360 degrees. So adding all this up, we're going to have 5x plus 110 plus the 75 plus the 2x equals this 360. So this will give me 7x plus 185 equals 360. Subtract the 185 from each side. So subtract the 185 from each side, and I end up with 7x equals 360 minus 185 is 175, and then divide by 7, so x will end up being 25. So since x is 25, we can find what A to B is, and that's just 5. The measure of arc AB is just 5 times this 25, which is 125 degrees. So hopefully this helped. Check the calendar for your homework. It's out of the Big Ideas book. And hit that like button and make sure you're subscribed. All right, good luck.